Welcome back to the Explore YouTube channel. So in this video, we're going to focus on the particular question where you will be given the array, and what you have to do is you have to find the maximum element or the maximum number out of the array. So let's say the array given to us is something like this, and let's say 1, 5, 7, 11, and 3. So I see the max value in my array is nothing but 11. So again, this is kind of similar to the previous question which we have done. The very first thing which comes to my mind is, okay, I'll sort the array, and once I sort the array, let's say in descending order or ascending order, so I'm gonna get, let's say I'm gonna sort the array currently in ascending order. So once I sort it, I'll get something like 1, 3, 5, 7, and 11, correct, right? And once I have the sorted array, correct, I'll get the very last element in Python. Since I'm doing in Python, I can get it using array at the negative indexing, which means this is going to take the last element, or in other programming languages, I can simply take n minus 1 as well, where n is nothing but the length of my particular array, which will be, again, if it's not given, you'll be definitely able to compute it. But I see this sorting time complexity would um, be n log n, which is completely fine. But again, I want to do it in big O of n time. How will I be able to do that? I'll say I'll have something like max value, which will be initialized to at the very beginning negative infinity. Yes, you are right, negative infinity. 0, 1, 2, 3, and 4th indices. So these are the indices. I'll access them one by one. I'm at the 0th index. Is 1 greater than minus infinity? Yes, I'll update it. I'm at 5. Is 5 greater than 1? Yes, I'll update it. I'm at 7. Is 7 greater than 5? Yes, I'll update it. I'm at third index where the value is 11. Is 11 greater than 7? Yes, I'll update it. I'm at the fourth index where value is 3. Is 3 greater than 11? No. So I won't update this. I'm not going to update this. So I see at the end of the day, or at the end of the loop, the max value is going to be assigned to some value which is 11, which indeed is my answer, right? I can see from here itself. So what is the time complexity for this approach, wherein I am doing some operation like max of my previous max value, comma, array of ith, like the element in the array at the ith location or the index. So the time complexity would be apparently big O of n, where n is the length of the array, because I'm just traversing the array once in a linear format, and hence it kind of speaks up for the time complexity. So let's try to code it out. I'll create this file here. Let's say the file name is maxelement.py, and let's say I'll have something like defined max element, and I'll have the array as the input and the length of the array n. Great. I'll have some variable known as max value, which is initialized to currently float of negative infinity. Pretty simple and straightforward, right? For I in range, let's say n, then I'll say, okay, max value is going to be maximum of whatever my previous max value was and the current element at the ith location or the ith index in the array. And once this process is done, again, I'll be happy enough to return whatever my max value is. And that's pretty much it. This is going to wrap up for the problem. I hope the explanation was clear enough. If you found the video helpful, please make sure to like the video and subscribe the Explore YouTube channel, and we'll meet in the very next video. Thank you.